TV screen. All right, the hard thing about this is I got a number out front, and a lot of times when the number's out front and they mix the terms up, we tend to want to put it in standard form, and that's really, one of the recommendations is one of the things to try is put this in standard form. But if I put this in standard form, it's actually not what I want to do here, because you don't even know how to factor it that way yet. There is a way you could do it, but it's very painful. If I were to put it in standard form, I could put the 80 p squared q squared first, but it's a negative 80, so that negative has to go with it, and we never factor with a negative number out front. We never have that going on. It's just not what we do. It's hard to think of doing that. So I could have put that first and put 11pq plus 1, but ooh, what a mess. Nobody wants to go there. Not even the author of this book wants to go there, okay? So we know that we could do it, but is it the thing to do here? The answer is no, and the reason the answer is no is because this number out front here, there's only one way to get it. Isn't the only way to get 1, positive 1? Actually, you could say negative 1 times negative 1, but I just got through saying we don't put negatives on the first term when we factor. So that means there's only one way to factor 1. It would be 1 times 1, right? Okay. Since it's a 1, it makes this problem a whole lot easier. I couldn't do this with just any problem with a number out front. But since it's 1, this is going to make this an easier problem to do because I can just go, normally I have like an x squared out front and there's a 1 in front of it that we don't write down. This is why this one can be done the way we're doing it. We could say now, I'm going to multiply to get that number on the end, the negative 80 part, and I'm going to add to get the number in the middle, the coefficient of that middle term is plus 11. Now, let's see, we could write down everything we could think of. Let's think about just the number 80. 8 times 10 is 80, but those would have a difference of 2. That's not going to work. Let's see, 2 times 40, not going to work, is it? They have a difference of 38. That's not my middle number. What about, this one is actually, I think it's like 15 times 6 is 80. 15 times 6 is 8. No, that's 90. Let's try 16 times 5. Let's see if that works. Yeah, 16 times 5. See how I'm having to think a little bit about numbers? I know 5 goes into 80, so I was kind of like, well, how many times would 5 go into 80? 16 times. What's the difference in 16 and 5? It would be the 11, wouldn't it? Okay, so I know I'm on to the right numbers. I got to tweak the signs, though. I want a positive 11. Which one will I put the minus on? The 5. 16 minus 5 is 11. That's the same as saying 16 plus negative 5 is 11. So I got my numbers. I want a plus 16 and a minus 5, but I got this p squared q squared here. So since there's two things squared, I'll want one of each in each section. I want a p and a q, because if I think about multiplying that last term out, p times p would be p squared, and q times q would be q squared. Let's see if that works. I'm kind of using some logic here to think about how I could do this. Let's check the little rainbow thing I talked about to check those middle terms. 16pq times 1 is 16pq. Always put the letters in alphabetical order, right? And then if you do the other little smiley face or rainbow there, 1 minus 5pq is a minus 5pq. 16pqs minus 5pqs is 11pqs. Did I get the right thing? Do you see that if I've used this, I get the number part right, and I'm just kind of figuring out how am I going to get this PQ in the middle? Oh, there had to be one in each slot in order to get both of those middle terms to be PQ terms. To me, this is a very tricky type problem. He's really working on being very rigorous here when he gives you a problem like this. This is not a problem you'd see in a lot of math textbooks for Algebra 1.